not in the habit of taking orders from a machine.
Hi, I'm Paul Wealls, Product Manager and Community Manager here at ADLINK, running the 2020 Vision Hack for finding industrial machine vision solutions from the community. We have a great prize of $10,000 and you retain your IP, and we go to partnership and help you validate that solutions market. Very exciting hack, and we have 4 themes for you to consider. Let's take a look at those themes.
Let's take a look at the computer vision themes for the 2020 Vision Hack. Manufacturers leverage powerful, real-time data from the IoT to increase uptime, perform preventative maintenance, enhance productivity, improve mobile accessibility, and a host of other benefits, like fault detection and enabling higher quality production and quality inspection. Distribution businesses have requirements for asset management, business process efficiencies, and new business models. Considerations like warehouse management, tracking and tracing assets in real time, security and transparency, monitoring asset movement within and around the facility to prevent theft or the misplacement of goods. Workplace safety. Thousands of workers die in industrial accidents each year in the world, and a huge amount suffer from non-fatal work-related injuries. Workers, employers, and insurance companies collectively face billions of dollars of direct and indirect costs due to industrial accidents, and individuals suffer unnecessarily. For example, think about personal protective equipment, PPE detection, ensure people are wearing the correct equipment for hazardous environments. Fall detection, enable identification and notification systems when workers experience injury or equipment is damaged. The energy sector is adopting the use of computer vision to enable smarter, automated, and more effective sensor data collection. Actionable data available when and where it needs to be. Example uses are wind energy producers identifying maintenance such as dirt accumulation on wind turbines, dead insects, and cracks in foundations or towers. In mines, automatic detection of anomalies in mines, for example leaks, fires, smoke, or even production blocks.
So they're the themes. We're looking for solutions. We're using vision as a sensor to help in those environments and in those situations. We're partnering with Intel and OpenVINO, utilizing their technology with the inferencing and chipsets that they have. But then you've got to think about how you get the data moving around and such like, and that's where ADLINK comes into its own with the ADLINK Edge platform. So I'm here today to share with you on how we do that as ADLINK. So let me give you some insight here. Traditional view of IoT is more of a north-south type of thing, okay? So as I'm sure everybody's aware, and we hear about IoT all the time, IoT is, in the standard sense, it's simply connecting devices, things, generally with sensors, to send data back to the data center or cloud. This data is then visualized and enables analytics to deliver value of the data. In some cases, this evolves to enabling a reaction to the data to tell the thing to do something. This action is then pushed to the device to act upon the request. This is what we call north-to-south data. This is great when you have individual devices that do not need or rely on communicating with other devices nearby and making something happen in real time due to something happening with something somewhere else. For example, with industrial use cases. Risks and concerns with industrial use cases is scalability, cost, latency, bandwidth, and security due to the requirement of being constantly connected to the internet and sending and receiving data frequently. As an example, an autonomous car can generate 4 terabytes of data every day. Facial recognition is 250 megabytes per second. You get the idea of the amount of data that is potentially going to flow across the networks. At present, many organizations rely on a centralized server-client paradigm to authenticate, authorize, and connect different nodes in the network. This model is sufficient for current IoT ecosystems, but with the growth of the number of devices connected and the volume of data grows exponentially, bottlenecks will occur and inevitably cause issues. Such systems will require huge investments and spending in maintaining cloud servers that can handle such large amounts of information exchange. And entire systems can go down if the server becomes unavailable. The future of IoT will very much have to depend on decentralizing IoT networks. Part of it can become possible by moving functionality to the edge, such as using fog computing models, where smart devices such as IoT hubs take charge of time-critical operations and cloud servers take on data gathering and analytical responsibilities. The cloud will certainly not disappear. We will still need data centers for many other use cases that require heavy computation and for storage. Computing at the edge is the future. This also leads to the use of peer-to-peer communications where devices identify and authenticate each other directly and exchange information without the involvement of a broker. Networks will be created in meshes with no single point of failure. This model will have its own set of challenges, especially from a security perspective. So what's machine vision AI and what's the value with edge computing? Well, machine vision is a rapidly growing branch of AI that gives machines sight that is comparable to our own. The advancements made in the field of machine vision is down to researchers applying specialized neural networks to help machines identify and understand images from the real world. As an example, the ADLINK team has been working with partners to provide a solution for cookie box distribution, using vision as a sensor to ensure the tailored boxes of the assorted cookies are correct. The original process for the cookie box was a very manual one, which suffered errors due to utilizing temporary staff and a lack of logging of the boxes pre-delivery for quality assurance purposes. The solution enables the box's contents to be validated against the stored manifest to ensure that the contents are correct prior to distribution. The solution also takes a picture of the box and is stored in evidence systems for QA purposes. As you can see, the solution identifies the cookie boxes and identifies that by the color of them and the shape of them. The color represents the flavor. This then checks against the inventory list of that order. If correct, it flashes green and it takes an image of the order for quality assurance. If wrong, it flashes red and the box is removed and corrected. This requires a camera as a sensor to read the barcode to identify the box on the production belt and also of the contents of the box to check against the inventory for that specific order. There is a connection to the inventory system, a connection to the cloud to store the data. The model and the inference engine and a number of other applications to make this solution successful. The computing needs to be at the edge to ensure that you don't block up the networks and run with latency and bandwidth issues and being able to run in real true time. Really an effective solution. So the ADLINK Edge platform uses the ADLINK DataRivet. This enables users to securely connect, stream, and control IoT data to focus on making decisions based on information, with the knowledge that the challenges of data movement, security, etc. are all taken care of. Right data, right place, right time. It's fast, reliable, scalable, with the freedom to move any data anywhere, realizing business value and innovation, north, south, east, west data movement. Proven technology, widely adopted in aerospace and military applications already, and has been for a number of years. A common architecture that connects sensors to data, to edge, and to enterprise, interoperability between vendors and spanning industries, which manages the complexity in infrastructure and not code. The ADLINK Edge platform has been developed with the user in mind to enable solutions to be built quicker with less code and more configuration. A key enablement of the ADLINK Edge platform is the app marketplace. These applications enable intuitive configuration, less code, to enable the data to move easily across the data river. There are 7 key segments of applications. There's cloud connectors, which is the obvious, connecting to the cloud. Historian with things like Influx, Visual Connect with things like Basler, GenCam, OpenCV, Edge Analytics, and IT connectors like MQTT, and OT connectors like Modbus. These applications are built using the ADLINK Edge SDK. So if you have a specific application that you want to bring into this ecosystem, you can simply build one using the SDK, which is freely available on the ADLINK website. You also have a number of ADLINK tools to help you even further, like Profile Builder and Device Management, along with a wealth of AI vision applications, which we will cover in detail in another episode. We have developed ADLINK Edge to be more configuration, less code as mentioned, enabling you to prototype and deploy more intuitively and easier than before. And when ready, you can easily scale to production. So as you can see in this picture, there are a number of applications here in regards to vision. So, being able to initially set up the device and configure it, building a profile, to then collect the data. You then get the data to where you need to then train it. Once it's trained and you've built a model, you then use Model Manager to bring it back and push that onto the device and run the model through and start to get the output from that data. and from the model. You then start to build out the ecosystem to create the reactions you want. Checking the model confidence, but then also connecting to the cloud to create reactions if you wish. OT connection to control things, machines, or simply even turning lights on, sending an email or a text message. As you can see on the Hackster website, there are a number of projects on there for you to take a look at. Once you've gone through from your POC using a device like Vizi-AI, which you do receive as a winner for phase 1, which has the Intel E3940 CPU and the Myriad X VPU. Once you've built your solution and you've proven it and you've built out a proof of concept, you could build a case for that device and use that, or you could then scale out. You could then move to a camera, an industrial camera like the neon cameras that ADLINK have, which has very similar power in regards to the Myriad X, but it has the higher 3845 Intel CPU and a number of other hardware in regards to the image sensory. You can then start to scale out to the gateways, adding multiple cameras and streams to do that computing using the same profile that you've built across these devices, just more configuration. So the Vizi-AI, as mentioned, is an industrial machine vision AI dev kit. It's a single board and it's very much plug and play hardware and software, enabling a faster, easier and scalable starting point, which is why we're giving these to the winners of phase 1 to enable them to be able to build their prototype very quickly and easily to win phase 2. And you get all the ADLINK Edge software included in here that you need, and you'll also get the support from ADLINK and Intel as phase 2 winners there with direct contact using Slack. So there you have it. That's the ADLINK Edge tools that you'll be receiving. We are going to have some further episodes giving you some more detail in regards to the applications, and also we'll be doing a joint one with OpenVINO discussing how you utilize the output data from the inferencing with the model that you've built as well. Thanks very much, and look forward to seeing you on the next episode.